Hi and welcome to this simulation. Today I want to simulate um, friction steel welding because in the last month many of people asked me about this simulation, and then now I want to simulate this using Lagrangian method. Already I simulated this in Eulerian method, now in Lagrangian method. So we need to create geometry. Already I create two geometry workpiece, 3D solid, 3D solid deformable extrusion, and you see the sketch section. Okay, and the tool shell, discrete rigid revolve shell, and you see this sketch of shell. And okay, and assign the reference point to the discrete rigid part, and okay, this module is complete. You need two parts for the simulation. Okay, but go to the material property. The material in the material property process module, you need many data about your material, like steel or aluminium or other material. The material like this Excel file, like that. Conductivity dependent on temperature, density, temperature, elastic, Young model, Poisson ratio, and temperature, expansion coefficient, lateral heat, plastic, and specific and heat. So I create this material for steel, and you see the material property. Okay, plastic and other specific heat. Good. Create a section for this part. This section is solid homogeneous, and assign this section to this part. Okay, and the material property is completed. Go to the assembly module. In the assembly module, you need a partition for workpiece, because in the step module we should use the all-in method for this simulation, because if you don't use this procedure, your simulation will be determined by distortion error. So we need to specify heat zone by using this partition. Escape, then extrude along this direction. Okay, and you need to fix two parts like this. Very good. Step module. You need the step module, 3 step. Step 1, in the step 1 you should create dynamic temp explicit the time. In the interaction module, you need to use the contact between tool and workpiece. This contact should be surface to surface for using friction coefficient depend on temp, like this. This is extracted from the journal, and okay, in the step 1, create surface to surface contact explicit, the master surface is tool surface, and this second surface or slave surface or the cube surface height area. So contact interaction property using coefficient, friction coefficient depend on temperature, and okay, this is enough. And create rigid body from the tool and select the reference point for controlling this. Okay, that's enough. And loud module, you need to create predefined field for temperature. Your cube initial temperature for your cube is 25. Okay, boundary condition. So select all around the cube and select the encaster boundary and create a boundary condition, displacement, rotation for a reference point and fix all of the freedom in the step of initial. In the step 1, modify this on a small moving along a great direction like this, and use an amplitude for this. This amplitude 1 adapted by time step. Okay, and the step 2, deactivate this 0, and UR2. In this step we have velocity rotation about a correct direction, so create a boundary for this reference point, and the rotate velocity is 1900, and modify this in step 3. Yes, U1 along x direction is right, and use amplitude 2 adapted by time step 2 time 5, step 2 5 time 5. No, this is incorrect. 5 1. Okay, step 2, yes. Okay, check boundary. This is a temp. Okay, for this, yes. And check the boundary. Yes, the boundary condition occur. So go to the mesh module. You need a fine mesh, but I use this mesh because this is an example just for showing the procedure, and the time for this example is so big and I can't this. I didn't want this, so this is good for my work. And so element library, explicit, geometry order, quadratic, select cube, temperature, displacement, and for hourglass use a combine and way factor 1. This is used in a model by main distortion like explosive forming. Okay, for the rigid. Okay, so create a job module, but we can need to edit this. Yes, absolute zero temperature, 200 73.15, and Stephen Boltzmann constant 5.67 e minus 6 power 6. Okay, and create FSW Lagrangian. Okay, and we can submit it and waiting for the result. So after nearly 7 minutes 0.05 second so go to result, because I want to determine this simulation, because this simulation will be causes to destroy my computer. So good, and no, yes, okay, so temperature, and sorry, okay, check the monitor for 1692.9. the time is 0.22. so press result and check the esters one misses. Okay, this is the esters distribute, so we want to check, look, this zone you need to increase remeshing, for avoiding this shape of element. You need to increase remeshing. So select the temp distribute. You see the temp from 25 increase to 1.9049 e power 2. So you need to increase the temperature to time, and so okay, the time is okay, Q, that's the equivalence. Okay, this is a procedure of frictionless welding, but you need more time. You need a big computer for running this. My computer is weak, and this simulation caused to destroy my computer, so I kill it. You need to